This is Activity 1.2.1 over different energy sources. I have been assigned the energy source of coal and have elected to do a video. To begin, as everyone knows, coal is a non-renewable source of energy. It is created by living things dying and becoming peat, which is buried under the earth and compressed under extreme forces of pressure and heat for millennia until it transforms into coal, a clump of mostly carbon that burns well enough for us to use in power production. To renew this, one would need to collect large amounts of organic matter, and then provide enough heat and pressure to mimic that which has been done over millennia, which is just not conceivable for us to do at all, let alone in using less energy than that which the coal created would be capable of providing. So, moving on, just as is the case for every single energy source out there, from wind to geothermal to nuclear to natural gas and oil, hydroelectricity, get the picture. To produce energy, you need to spin a turbine. The turbine is there to catch pressure, producing torque, which is used to spin magnets between coils of wire, the end result of this being the movement of electrons we know as electricity. For the majority of power production methods, including coal plants, this is done by heating water and using the resultant steam to spin these turbines. In coal plants, it typically goes like this. The coal is pumped into the plant, going through a preliminary pulverization before being dumped into the furnace. This is also referred to as the boiler, as the coal here being burned causes water that is being pumped through pipes that run through this furnace room to boil. By the end of this pipeline, the water has become steam and flows through these turbines, producing the torque necessary to create power. At this point, the steam enters a condenser that cools it back into liquid state and recirculates it through the system to repeat the cycle. The condenser is fueled by water pumped through a separate, isolated pipeline, usually from a nearby river. With cooling down this water, the coolant water itself will start to heat up and ends in its boiling. So coolant towers are set up for it to flow through. Usually when you pass by a power plant, the enormous funneling up cylinders are billowing this steam rather than the coal pollutants one would normally think to be the case. These coal fumes instead billow out of the much smaller and thinner pipes that maintain a constant diameter, rather than these much more massive funneling ones. In terms of infrastructure requirements for a coal plant, it's around mid-level difficulty, less difficult than something like a nuclear power plant, but more difficult than your typical solar field. Firstly, you are going to need the source of the power itself, coal, pumped in via some means. You'd normally have this done by trucks dumping it into a coal slot of sorts that would slowly feed it through crushers and pulverizers, and eventually the conveyor that would dump it into the furnace room itself. Speaking of which, you would need the furnace room itself built, along with the isolated pipeline to carry the water used as turbine propellant. You'd need the turbine and the accompanying generator, the transformer that it hooks up to so as to link it to the actual power grid. You'll need the nearby river and pump to use as coolant for the turbine propellant pipeline, and finally, the chimney and its filters to soak up the majority of the pollutants, plus the cooling tower to match the coolant pipelines. Now, for emerging technologies in the ways of coal power, there is IGCC plants. This stands for Integrated Gasification Combined Cycle Plants. This is a major innovation in coal power. Coal plants are one of the leading contributors to pollution and global warming in this modern era, but IGCC plants are helping to limit this. They are using advanced techniques to not only limit the amount of pollution caused by up to 90% or more, but to increase the efficiency tenfold. They do this by turning the coal into a high-pressured gas, filtering it of its pollutants and burning it in this gaseous state. The most efficient of these plants, the cleanest and most efficient coal plant for that matter, across the entire planet, is the Edwardsport plant in Knox County, Indiana, owned by Duke Energy. That wraps it up. Here are your conclusion questions.